s minus t. So we need two angles that will either add or subtract, and we have to look at angles like 30 degrees, 45 degrees, and it goes on. 60 degrees, 90, 180, and 270. So we want to look at, since it ends in a 5, we know it has to be 45. So that would give us 45 and also 30. And since this is a positive 15 degrees, then we would be working with a negative tangent, 45 degrees, and we are going to subtract, right? Because 45 minus 30 is 15. Okay, so that means we have to work with tangent. That's going to make this a negative tangent 45 degrees minus tangent 30 degrees over 1 plus the product of the two, tangent 45 plus tangent 30. Okay, so here we have a negative here, and then we have, that's going to make it tangent 45, that's going to be a 1, minus tangent 30 is square root 3 over 3. And then this will be 1 plus, and then again tangent 45, right here, that'll be 1 times tangent 30, which again is going to be square root 3 over 3. Okay, so now we need to get a common denominator, right? So we need to multiply 3 over 3 for this one and 3 over 3 for this other one here. So that, here we have a negative 3 minus 3 over 3 minus square root 3 over 3, and that's going to be over 3 plus square root 3. So we can go ahead and just make this all one denominator at 3, right? At 3. Okay. So at this point, we can go ahead and cancel the denominators out, right? Move this negative down here. Okay, so this is what we've got so far. And let me just make that, there we go. Okay, so this is what we've got so far. We've got a negative 3 minus square root 3 over 3 plus square root 3. But we can't leave a radical in the denominator. We have to rationalize the denominator. So we have to multiply the conjugate. So we're going to multiply 3 minus square root 3 over 3 minus square root 3. And we're going to FOIL. Okay, so that means we're going to have a negative here. And we've got 3 times 3, that'll be 9. And then we've got 3, a minus 3 square root 3, right? And then this will be a minus 3 square root 3. And then here, this will be a plus, negative times negative is a positive, square root 3 squared, right? And so that square root will go away. And in the denominator, we're going to have 3 times 3 is 9, right? And then this will be a minus 3 square root 3, and then this will be a plus 3 square root 3, so those two will cancel out. Minus square root 3 squared. So here we have a negative, and we've got a 9, this 3 square root 3 and a minus 3 squared, that's going to be a minus 6 square root 3, and this square root 3, that's going to change, right? That'll become a plus 3. And now in the denominators, we have 9, and these 3 square root 3's are going to cancel. And then this minus square root of 3 squared, that'll just be minus 3. So we've got a negative, and now 9 and 3 is going to be 12 minus 6 square root 3, and then here 9 minus 3, that's going to be a 6. So we're going to, now this negative here, that has to be distributed into everything. So this is off to the side, so that's not just for the 12, that has to go into both, because this negative is off to the side like that. So that makes this a negative 12 over 6, and then this will be a negative times negative, that'll make that a positive 6 square root 3 over 6, and 6 goes in negative 12, that's going to be a 2, and here the 6 cancels, and so we get a negative 2 plus square root 3, and that is our answer. Okay. Let's say that we're looking at problem number 25 in the book. And it says, prove the identity. We want to prove that sine of x minus theta is equal to a negative sine x. Or not, this will be x minus pi, rather. Okay, so we want to use our difference equation for sine. And so we know that sine s minus t is sine s cosine t minus cosine s sine t. Okay, we know that. So we can change this to sine x cosine pi minus cosine x sine pi. Well, here's pi, right? And that coordinate is negative 1, 0. And that's cosine and sine, right? So cosine at pi is a negative 1. So this is like saying sine x times a negative 1.